Today's lesson is about the last part in the complex number, which is about the locus. So in total, there are 3 loci that we need to know how to sketch in this part. So for the first one, let's have a look here. It's about circle. So first of all, you have to recognize the equation of the circle, which is stated over here. Modulus z minus a equals to k. So what does z, a, and the k means? Okay, the explanation is over here. Z is a moving point, which is the locus. A is a fixed point, which is the center. And the k is the radius. So let me jot down over here. The A represents the center, and the k represents the radius, where the z is the moving point, which is the locus that we are sketching. So this equation, it means that in this chapter, modulus means the length. The length or the distance between the locus z and the center A, it should be equals to the k. So what you need to take note here, you got to make sure that it's a negative sign over here. So that's the general formula for a distance, means distance between z and the A. So you have to make sure that it's a negative in between these 2 points. So have a look at the diagram at the side. Let's say this is the center A, and then the locus z is here, the circle that we are sketching. So let's say the z is over here, then distance between z and A, it should be equals to the k, radius. If my z is over here, then when you measure for the distance between z and A, it should be equals to k as well. So now if my z is over here, distance between z and A is also equal to k, which means the z is all around the circle here. That's how it forms the locus of a circle. Let's have a look at the example here. There are 3 examples. So let's say have a look at the part A. Before we can sketch the locus of a circle, we got to figure out what's the center and what's the radius here. So from this equation, obviously the 2 is the radius. So I write down the radius as 2. And what about the center's coordinate? So have a look here, it's a minus. So it's a distance between the z and the point 1. So the point 1 is without the I. That means the 1 represents the real number. So if I write it in the coordinate form, it should be 1, 0. So from here, since we have already figured out what's the center and what's the radius, then we can plot it accordingly. So make sure the x-axis and the y-axis, which is a real axis, and the imaginary axis, the scales are the same. So let's say you use a 1 cm to represent 1 unit, make sure the same happens for the imaginary axis. Because if the scale is different, then your circle will become an oval. Alright, so now the center is 1, 0. So let's say here is a 1, 0. Then the radius is 2, which means at the center here, you measure 2 units. 2 units from the center. 2 units from the center and connect it as a circle. Alright, so it's roughly like this. So what you need to do here is just to label the center is 1, 0 and the radius is a 2. Alright, just simple as this. Have a look at the B. Let's figure out what's the radius and what's the center here. So for the B, radius obviously is a 5. As for the center, okay, notice that it's a minus here. So it's the distance between the locus z and the point 3 minus 2i. So if I'm to write it in the coordinate form, it should be 3 and negative 2. So prepare the real axis and the imaginary axis and plot the center 3 and negative 2. You can write the center 3, negative 2, or you can label it at the axis here. And radius 5. So from the center, 1, 2, 3, 4, 5 is about here. 1, 2, 3, 4, 5 is about here. So the circle should be something like this. With the radius 5. So during the exam, of course, you can use a tablet or your iPad to sketch it. So what to do is, if you can't sketch it accurately by freehand, then you better prepare a compass to sketch a perfect circle. Because if your circle is not accurate, then it will affect your answer in the next part, in the following part. Okay? Alright, so this is for the part B. Let's have a look at the C. So for the C, radius is a 1 here. But what about the center? For the C, okay, it's a minus here. So distance between the point Z and this point. But the problem is, the minus, we have to factorize it and make it become this form. So let me rewrite the C. It should be modulus Z minus a point, a distance between Z and a point. So the point, it should be 2 plus 2i after you factorize the negative out. And that's why the center here, it should be a 2, 2. So to sketch this, the center is 2 and 2. Here, radius is just a 1. Okay, so this is how we sketch the circle's equation. Besides equation, there'll be also inequality for the circle. So you won't be seeing the equal sign here, but it's more than or the less than sign, the inequality sign. So the method is the same. So have a look here. Same thing. First thing that you have to do is to figure out the center and the radius. So radius here is a 3. Center here is a -1 plus I. Have a look here how I change it. Okay, you prepare the modulus here and prepare 2 points, Z and the other point, and put a minus in between the 2 points. So here, if you factorize the minus from the 1 minus I, then it becomes -1 plus I here, and less than or equal to 3, which means the center's coordinate, it should be -1 and 1. Okay, so from here, plot the center, -1 and 1, so it's somewhere here. Radius is 3, so from the center, measure 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So roughly, you know that the circle is this. Now, have a look at the inequality sign here. So this inequality sign means you have to shade somewhere. When it's equals to 3, it's just the circle only. But now, other than the equal sign, there's a less than sign. So the less than sign means you have to shade the area inside the circle. Okay, so let's shade inside the circle here. This is how we sketch the locus for the circle's inequality. So remember, less than means you have to shade inside the circle. The equal sign means the circle line itself. This is for the A. Then have a look at the B. So same thing for the B, let's figure out the radius and the center first. The radius obviously is a 2 here. And the center is, okay, again, you change it, prepare a modulus, prepare a Z minus a point. So the point should be -3i. So the center is 0 and -3. So now let's sketch the circle first. 1, 2, 3, -3 over here, and then the radius is a 2. Okay, so since the inequality shows more than 2 and it's without the equal sign, it's not more than or equals to 2, because when it's equals to 2 it means the circle, but now they only want more than means outside of the circle. You only need the shade outside the circle, but the problem is there's no equal sign. That means they don't want to include the circle's line. So what to do in this case is the circle, instead of drawing the circle in solid line, we got to draw the circle in dotted line, because the circle is not included. It's not like the part A. Have a look at the part A. There's equal sign here. That means they want to shade inside the circle. The less than means inside the circle. With the equal sign here means they want to include the circle as well. That's why the circle is a solid line. But then have a look at the B. It's just more than without the equal sign, which means the circle is not included. That's why I sketched the circle in dotted line. And more than means we shade outside the circle. Alright, so this is about the circle's inequality. Have a look at the second type of locus here, which is about the equidistance from 2 points. So the formula, the general equation is over here. Modulus z minus a equals to modulus z minus b. So this equation means the distance between the point z, which is the locus or the moving point, the distance between z and the a is equals to the distance between the z and the b, where the a and b are 2 fixed points. Okay, so have a look at the diagram at the right hand side here. Let's say we fix the point A and the point B over here and here, and this is the locus that we are sketching. Why is this line the locus that we are sketching? If this is a locus, that means the z is all over on this line. Alright, so now let's check. If my z is over here, then according to the equation here, the distance between z and a is equal to the distance between z and b. So let's check. So now if my z is over here, distance between z and a, is it the same as the distance between z and b? Yes, it is, right? So now let's check for another point. Let's say my z is over here, and you check for the distance. Distance between z and a is the same as the distance between z and b. And that is why z is all around here. And that's how it formed this line. And this line is actually the perpendicular bisector between the point A and B. Okay? Perpendicular bisector. Alright, so for this locus, when you see this equation where both sides are having modulus, it represents the perpendicular bisector. Same thing, you have to make sure that it's a minus in between the 2 points. Have a look at the example here. You are asked to sketch the locus, and for this locus, both sides are having modulus, means it's a perpendicular bisector. So you have to figure out what's the point A and the point B. So the point A comes from here, the point B comes from here, but you have to make sure that it's a negative here. Alright, so let's write the equation again. Prepare the z and the minus and the bracket for the other point. Z minus and the bracket for the other point. So have a look here. How to change this one into z plus 2? Okay, we have to factorize the negative from the positive 2. So which means here is a negative 2. So you see this negative multiplied with this negative, you get back the positive over here. And for the right hand side, since there's already a negative here, so the one inside the bracket should be a 2i. Which means for this point, point A, the coordinate should be negative 2, 0. For the point B, the coordinate should be 0, 2. So as usual, you prepare the imaginary axis and the real axis. Then now you're supposed to plot the point A and the point B. Point A is -2, 0 over here. Point B is 0, 2 over here. So what to do is, now we just need to sketch a perpendicular bisector. So no need to be too accurate, you just need to sketch it, because according to the question is the sketching. So you just connect the point A and point B by using dotted line as a reference line for you to sketch the perpendicular bisector. Perpendicular bisector means you got to cut this line into half, so about the midpoint you draw a 90 degrees line, perpendicular bisector, over here. Okay, so this line will be the locus that represents this equation, which is the perpendicular bisector.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with one or two past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.